Imagine spending millions developing a harvester that looks like something from the future, promising to revolutionize farming forever, only to have farmers laugh it off the field within months. That's exactly what happened to these 10 incredible machines. Today we're diving into the fascinating world of vintage combines that had everything going for them on paper. Brilliant engineering, cutting-edge technology, stunning designs, but absolutely bombed in the real world. These weren't minor failures, these were spectacular, expensive disasters that became cautionary tales in agricultural history. Some were too complicated, others too ambitious, and a few were just plain weird. Let's explore 10 vintage combines that looked revolutionary but completely flopped. Number 10. The Gleaner E3 with rotary separator 1979. We're starting with a combine that should have been a winner. The Gleaner E3 was introduced in 1979 with a revolutionary rotary separator system that promised gentler grain handling and higher capacity than conventional combines. On paper, it was brilliant. The rotary design would reduce grain damage, increase throughput, and give Gleaner a competitive edge against John Deere and International Harvester. The prototype demonstrations were spectacular. The E3 processed crops smoothly. The grain quality was excellent, and capacity numbers looked impressive. Gleaner invested heavily in production facilities and marketing, confident they had a winner. Dealers were excited, and pre-orders rolled in. Then farmers actually put them to work, and reality hit hard. The rotary separator, while gentle on grain, had a fatal flaw. It was incredibly sensitive to crop moisture and conditions. In slightly damp conditions, the rotor would plug constantly, bringing harvest to a grinding halt. Farmers would spend hours clearing jams instead of harvesting. In dry, dusty conditions, the design created so much dust inside the machine that visibility became dangerous and maintenance was a nightmare. But the real killer was complexity. The rotary system required precise adjustment for different crops and conditions. Farmers who were used to making simple concave adjustments now needed to understand rotor speed, cage clearance, and separator geometry. Many simply couldn't get it dialed in correctly, resulting in poor separation and grain loss that made the machine uneconomical to operate. Within 2 years, Gleaner dealers were flooded with unhappy customers wanting to trade them in. The company tried fixes and updates, but the damage was done. By 1983, the E3 was quietly discontinued, replaced by more conventional designs. Thousands of E3s were sold at heavy discounts or traded in for huge losses. Today, they're remembered as Gleaner's most expensive mistake, a cautionary tale about over-engineering a solution to a problem farmers didn't really have. Number 9. The Massey Ferguson 860 Hillside Leveling Combine. 1975. The Massey Ferguson 860 was designed to solve a real problem. Harvesting on hillsides meant conventional combines couldn't keep their cleaning shoes level, resulting in massive grain loss. Massey's solution was a complete self-leveling combine that could automatically adjust to keep the separator and cleaning system perfectly horizontal on slopes up to 45. The engineering was extraordinary. The entire separator section could pivot independently from the chassis, controlled by hydraulic cylinders and sensors that constantly monitored tilt. In demonstrations, the 860 would crawl across impossibly steep hillsides, its separator staying perfectly level while the wheels climbed at crazy angles. It looked like magic, and it genuinely worked. So why did it flop? 3 words: complexity, weight, and cost. The self-leveling system added over 3,000 pounds to the machine, making it dangerously unstable on the very hillsides it was designed to harvest. The hydraulic system was a maintenance nightmare, with dozens of hoses, cylinders, and sensors that failed regularly. Repairs required specialized knowledge and parts that were expensive and often back-ordered. But the real killer was the price. The 860 cost nearly double what a conventional combine cost. Farmers did the math and realized they could buy 2 regular combines and carefully harvest hillsides manually for less money and less headache. Those who did buy 860s found that while they worked well on moderate slopes, they were overkill for most conditions and problematic in the extreme conditions they were designed for. Massey Ferguson sold fewer than 500 units worldwide before quietly discontinuing the model in 1960s. Most were eventually converted back to conventional fixed separators or scrapped entirely. The 860 taught the industry an important lesson. Sometimes the solution is more problematic than the original problem. Number 8. The International Harvester 915 Diesel-Electric Hybrid. Long before hybrid cars became mainstream, International Harvester tried to create a hybrid combine. The 915 used a diesel engine to power generators that drove electric motors for all functions: threshing, separating, cleaning, and propulsion. The advantages seemed obvious: infinitely variable speed control, regenerative braking, reduced mechanical complexity, and improved fuel efficiency. ID's engineers were genuinely brilliant. The 915 prototype was smooth, quiet, and efficient. Electric drive meant no clutches, no belts, no mechanical wear points. Speed and power could be adjusted instantly with electronic controls. In controlled testing, fuel consumption was 15 to 20% better than mechanical combines. The future had arrived. Then came field testing, and the future crashed hard. The electrical system, cutting edge for 1981, was also fragile and temperamental. Dust and chaff infiltration caused shorts and failures. The generator and electric motors produced enormous heat that required complex cooling systems, which frequently failed in dusty harvest conditions. When something went wrong electrically, farmers couldn't fix it themselves. They had to wait for specialized technicians, often losing days of critical harvest time. Weight was another disaster. All those electric motors, generators, and massive battery banks made the 915 monstrously heavy. It compacted soil terribly and struggled in soft field conditions where conventional combines handled easily. The batteries alone weighed over 2,000 pounds and needed replacement every few years at enormous cost. The final nail came during the 1982 harvest season. Multiple 915s experienced catastrophic electrical fires when dust ignited from overheated motors. Though no one was seriously injured, the liability concerns killed the program instantly. IH recalled the few dozen 915s in service and scrapped the entire program. Today, maybe 5 915s survive in museums, reminders that being too far ahead of your time can be just as fatal as being behind it. Number 7. The New Holland TR70 twin-rotor Sperry, 1975. New Holland's TR70 featured a radical twin-rotor design that looked like it came from a science fiction movie. 2 parallel rotors processed grain simultaneously, theoretically doubling capacity while reducing grain damage. The Sperry New Holland name carried weight, and expectations were sky-high. The TR70's design was genuinely innovative. Feed entered the front and was split between 2 rotors that threshed and separated simultaneously. In theory, this balanced design would reduce vibration, increase capacity, and improve grain quality. Early testing showed promise, with capacity numbers that made competitors nervous. Reality proved far more complicated. The twin-rotor system required both rotors to receive precisely equal feed distribution. In real-world harvesting, especially in variable crop conditions, achieving equal distribution was nearly impossible. One rotor would overload while the other ran partially empty. This caused severe vibration, uneven wear, and frequent mechanical failures. Maintenance was a nightmare. 2 rotors meant double the wear parts, double the adjustments, and double the chances something would go wrong. Farmers discovered that keeping both rotors synchronized and properly adjusted required constant attention. The slightest difference in rotor speed or clearance caused grain loss or damage. Many operators simply couldn't keep them running efficiently. The breaking point came during the 1976 harvest. Multiple TR70s suffered catastrophic failures when the complex gear systems that synchronized the rotors failed, causing rotors to contact each other at full speed. The resulting damage was spectacular and expensive. New Holland tried to fix the issues with updated gearboxes and stronger components, but confidence was shattered. By 1979, the TR70 was discontinued, and New Holland went back to single-rotor designs that became quite successful. The twin-rotor experiment cost the company an estimated $50 million and years of market reputation. Number 6. The Allis-Chalmers All-Crop Harvester Series 2. Allis-Chalmers believed the future of harvesting was specialization. Their All-Crop Harvester Series 2 was designed as a modular system where farmers could swap entire harvesting heads and separator configurations in minutes to handle different crops. One machine could supposedly handle grain, corn, soybeans, and specialty crops just by changing modules. The concept was seductive. Instead of buying multiple specialized machines, farmers could buy one versatile platform and switch configurations as needed. The marketing materials showed operators swapping heads in minutes, transforming a wheat harvester into a corn harvester in the time it took to have lunch. The reality was far different. First, the modules were extraordinarily expensive. Buying the base unit plus multiple heads cost more than buying separate dedicated machines. Second, the modules weren't nearly as easy to swap as advertised. What looked like a 10-minute job in the promotional film required several hours of actual work, special tools, and careful adjustment. Most farmers gave up trying. But the fatal flaw was performance. By trying to be good at everything, the All-Crop Series 2 was mediocre at everything. The base platform compromised on capacity, power, and efficiency to accommodate the modular design. Dedicated combines outperformed it in every category. Farmers who bought them discovered they'd paid premium prices for a machine that couldn't compete with conventional designs costing less money. Alice Chalmers sold a few thousand units before admitting defeat in 1962. Most were converted to dedicated single-crop use or traded in for substantial losses. The modular concept wouldn't successfully return to combining until computer controls and hydraulics advanced decades later. The Series 2 proved that versatility without performance is just expensive mediocrity. Number 5. The Claas Dominator 108 SL Massey Air System. The German engineering powerhouse introduced the Dominator 108 SL with their revolutionary Massey air cleaning system. Traditional combines used mechanical sieves and fans. Claas proposed eliminating mechanical sieves entirely, using only precisely controlled air streams to separate grain from chaff. The system promised zero grain damage, dramatically reduced maintenance, and superior cleaning capacity. The demonstrations were incredible. The Massey air system would separate grain so precisely that you could barely find any foreign material. The lack of mechanical sieves meant fewer moving parts, less wear, and theoretically better reliability. Agricultural engineers were fascinated. This was genuinely revolutionary technology. Then farmers bought them, and the revolution collapsed. The Massey air system was incredibly sensitive to wind conditions. Even a moderate breeze would disrupt the carefully calibrated air streams, causing massive grain loss. Operators had to constantly adjust fan speeds and air gate positions to compensate for changing conditions. It required constant attention when farmers needed to focus on moving through fields efficiently. Dust was another killer problem. The high-velocity air streams generated enormous dust clouds that choked operators and reduced visibility to dangerous levels. The dust infiltrated every part of the machine, causing premature wear on bearings, belts, and electronic components. Maintenance costs skyrocketed as components failed far earlier than expected. The final straw was capacity. While the Massey air system cleaned beautifully in ideal conditions, its actual throughput in variable real-world conditions was disappointing. Farmers who had paid premium prices for revolutionary technology found themselves harvesting slower than conventional combines. Claas attempted fixes, adding dust suppression systems and improved controls, but the fundamental design was flawed. Production ended in 1987 after selling only a few hundred units. Claas learned valuable lessons and went on to build excellent conventional combines. But the Massey air experiment was an expensive embarrassment they rarely discuss. Number 4. The Minneapolis Moline Uni Harvester, 1953. Minneapolis Molin's Uni Harvester was supposed to be the Swiss Army knife of agricultural equipment. This bizarre machine combined a tractor, combine, and various implements into one unit. The concept was that small farmers could buy one versatile machine instead of multiple specialized ones, saving money and space. The design was genuinely weird. The power unit could detach and function as a standalone tractor. Attach the combine components, and it became a harvester. Swap attachments, and it became a baler, hay mower, or other implements. In theory, it was brilliant efficiency. One engine, one chassis, infinite possibilities. In practice, it was a disaster from every angle. First, being good at multiple tasks made it terrible at all of them. As a tractor, it was underpowered and awkward. As a combine, it had pathetic capacity and poor separation. As other implements, it was barely functional. Farmers quickly realized they'd bought an expensive machine that did everything poorly instead of anything well. The attachment system was nightmarishly complex. Swapping between configurations required hours of work, specialized tools, and careful hydraulic connections. What Minneapolis Moline marketed as quick change versatility was actually an afternoon project that most farmers attempted once and never tried again. They'd just use the machine in one configuration permanently, wasting its supposed versatility. Reliability was abysmal. The complex hydraulic systems that allowed the configurations leaked constantly. The detachable power unit connections failed regularly, leaving farmers stranded mid-harvest. Parts were expensive and often unavailable because dealers struggled to stock components for the dozens of different configurations. Minneapolis Moline sold maybe 2,000 uni-harvesters before discontinuing them in 1956. Most were scrapped or converted into dedicated single-use machines. The few survivors are bizarre museum pieces that remind us that sometimes versatility is just another word for compromise. The uni-harvester proved that farmers want tools that excel at specific tasks, not jack-of-all-trades contraptions that fail at everything. Number 3. The Oliver 525, self-propelled with automatic controls. We're in the top 3 now, and the failures get more spectacular. Oliver's 525 was supposed to be the first truly automatic combine. Using primitive computers and sensors, it would automatically adjust ground speed, cylinder speed, concave clearance, and fan speed to optimize performance based on crop conditions. The operator would simply steer, and the machine would handle everything else. For 1967, this was staggeringly advanced technology. Oliver partnered with aerospace companies to develop the control systems, using technology derived from aircraft autopilots and missile guidance systems. The promotional materials showed farmers relaxing while the combine optimized itself. The future of farming had arrived, or so Oliver claimed. The 5025's computer system was the size of a large suitcase, filled with transistors, relays, and primitive integrated circuits. It read sensors that monitored grain flow, loss, engine load, and crop moisture, then adjusted machine functions accordingly. When it worked, it was genuinely impressive, showing glimpses of what combines would become decades later. But 1967 technology wasn't ready for dusty, vibrating, temperature-extreme agricultural environments. The computer failed constantly. Dust infiltration shorted circuits. Vibration loosened connections. Temperature swings from morning cool to afternoon heat caused component failures. Sensors clogged with chaff or broke entirely. When the system failed, which was often, the combine reverted to manual operation. But manual controls were awkward and poorly designed because Oliver had assumed the computer would handle everything. Repair was impossibly expensive. Oliver dealers had no training on computer systems. Farmers certainly couldn't troubleshoot transistor circuits and relay logic. Every failure meant calling specialized technicians from Oliver who would fly out, often taking days to arrive, while harvest waited and crops deteriorated in the fields. The 525's biggest failure was being 20 years too early. Everything Oliver tried to do eventually became standard on combines, but the technology of 1967 simply couldn't reliably deliver it. Oliver sold only a few hundred before killing the program in 1969. The development costs nearly bankrupted the company's combine division. Today, the 525 is recognized as a visionary failure. Right idea, wrong decade. Number 2. The John Deere 8820 Titan with floating header system. At number 2, we have John Deere's rare failure. And when Deere fails, they fail spectacularly. The 8820 Titan was designed to be the biggest, most powerful combine on Earth. But its most revolutionary feature was the floating header system, where the entire cutting header was suspended on sensors and hydraulics that would automatically follow ground contours perfectly, maintaining precise cutting height regardless of terrain. The floating header system was engineering brilliance. Sensors detected ground contact pressure, and hydraulics adjusted header height hundreds of times per second. In demonstrations, the 8820 Titan would cruise across rolling terrain, its header gliding smoothly over bumps and dips like it was following a laser-level path. Grain loss from cutting too high was eliminated. The system was so advanced that competitors had nothing comparable. So what went wrong with a John Deere product? Scale and complexity. The 8820 Titan was massive, and the floating header system added thousands of pounds of hydraulic components, sensors, and control systems. The machine was so heavy it compacted soil severely and struggled in soft conditions. The hydraulic system required its own dedicated pump, cooler, and reservoir, creating a complex subsystem that was maintenance-intensive. The header system also had an unexpected problem. It worked too well. On uneven terrain, the header would follow contours so precisely that it would dip into low spots and catch rocks, stumps, or other obstacles hidden in the crop. Conventional headers would skip over these obstacles, but the floating header would dutifully follow the ground directly into them. The resulting damage was expensive and frequent. Operators learned to disable the system in rough fields, defeating its entire purpose. Cost was the final killer. The 8820 Titan with floating header cost 40% more than the already expensive standard 8820. Most farmers couldn't justify the premium, especially when the system caused as many problems as it solved. Deere quietly discontinued the floating header option in 1981 after selling only a few hundred. The technology was sound, but it was a solution looking for a problem that didn't really exist. Even John Deere learned that bigger and more complex isn't always better. Number 1. The Case IH Axial Flow 23044 Solar-Powered Sunburst. And here we are, the number 1 most spectacular flop in combine history. The Case IH Axial Flow 23044 Sunburst was supposed to revolutionize agricultural equipment by incorporating solar power. In the early 1980s, during the oil crisis, Case IH envisioned combines that would supplement diesel power with solar energy, reducing fuel costs and making farming more sustainable. The Sunburst was covered with solar panels, over 40 square meters of photovoltaic cells covering the grain tank, roof, and sides. These panels charged a massive battery bank that powered auxiliary systems like the cleaning fan, grain handling augers, and hydraulics. Case IH claimed farmers could reduce fuel consumption by up to 30% while demonstrating environmental leadership. The promotional campaign was enormous. Case IH positioned the Sunburst as farming's answer to the energy crisis. Media coverage was extensive. Environmental groups praised it. Pre-orders came from farmers wanting to be on the cutting edge of sustainable agriculture. Case IH projected they'd revolutionize the industry. Then reality destroyed everything. First, the solar panels added 5,000 pounds to an already heavy machine, making it ponderous and difficult to transport. Second, the panels were incredibly fragile. Harvest is dusty and abrasive. Within days, panels would be scratched, reducing efficiency. Within weeks, panels would crack from vibration and debris impacts. Replacement panels cost thousands of dollars each. But the real disaster was performance. The solar panels generated decent power in bright sunshine. But harvest happens in all conditions. Morning dew meant waiting for sun. Clouds meant reduced power. Dust in the air reduced efficiency dramatically. By afternoon, panels covered in dust generated almost nothing until cleaned, which required stopping work. In practice, the 30% fuel savings never materialized. Real-world testing showed maybe 5 to 8% savings in ideal conditions, far less than claimed. The battery bank was another nightmare. The massive batteries required constant monitoring and maintenance. They were extremely heavy, expensive to replace, and degraded rapidly in the harsh harvest environment. When batteries failed, which was common, the combine lost most of its electrical capacity and became nearly inoperable. The breaking point came during the 1983 harvest season. Multiple sunbursts experienced battery fires when the charging systems malfunctioned. Though no one was seriously injured, the images of burning combines covered in solar panels made national news for all the wrong reasons. Case IH's revolutionary sustainable combine became a punchline. The program was killed immediately, and Case IH bought back and scrapped every sunburst at enormous cost. The total development cost exceeded $80 million, making it one of the most expensive failures in agricultural equipment history. Maybe 10 sunbursts survive, hidden in Case IH's archives, a reminder that revolutionary ideas need mature technology to succeed. The Sunburst was 30 years ahead of its time, but being first to market with half-baked technology is far worse than being second with working technology. What surprised you most on this list? Did your family ever own one of these failed experiments? Share your stories in the comments. I'd love to hear about real-world experiences with these machines. And if you enjoyed this journey through spectacular agricultural failures, smash that like button and subscribe for more deep dives into farming history, vintage equipment, and the lessons learned from both successes and failures. Hit that notification bell so you never miss our next video. Thanks for watching, and remember, failure isn't the opposite of success, it's part of the journey. These magnificent flops made modern combines possible. I'll see you in the next one.